This can be done. So what we need to do is, I just draw a bigger circle. Can I should have to, huh? This question is a little bit tougher than usual. Okay, so what we need to do is, just draw the bigger one up here, so easier to see. So what exactly is happening here is, this trick is to determine this like that. We'll put these two lines like this and like that. No worries. Okay, pardon me for redrawing it to make it more clear. This is O, this is B, this is A, R and S, both are 90 here. These three things are equal length, then P and Q. So what we do is we change the color and we draw two radius. So the radius that we must connect is talking about here and talking about here, because we're only interested in one section, it's a trick part. Okay. So the trick part is, so I join with another color here, this line, and then I'm going to shade a little bit. They'll notice this part, this is the hard part to see that. So this extra part, let's say we color it in light green, or not green. Let's use this color or what? Let's see, what color is this? Okay, let's say like that. This is the secret. So this radius all is 1. So let's say we take the radius is 1. So now we're going to start the computations. So the radius equals to 1. And then you just saw that if we take this as theta, these three things are theta. How do I know that? Because AP, radius is 1 means AP or S is R theta. So R is 1 and then it's theta multiply. So it's the same for the other two. So this is theta. So it turns out this length is theta in value as well. Okay, all these three are theta in value, this length. So it's theta here, theta there. A little bit confusing, but it's true. So I want to calculate the sector POQ. So area of sector POQ. So if you go for the area of sector formula in radians, it will be half R square theta. So half R square theta means, what is the radius? So you can see the radius is 1. We assumed it because to do the proportion, everything in terms of 1, that is 1 unit per unit of the radius. So this is theta over 2, sorry. So this area is theta over 2, the entire POQ. Now I want to calculate the area of triangle POQ. Please take note of the difference. Area of triangle POQ. Put the symbol also double number, more clear. So we use this formula, half R square sine theta, using the area of a triangle where the two sides are isosceles, so it's R radius. So what we do is we calculate half 1 square and then sine of this theta itself. Okay, we don't know what's the value of theta just yet, but actually we know the value of theta. Do you know? No? I already know the value of theta. If you think about it, you'll see that theta is 1. Okay, this juncture on top of the theta part. Just a small note here. Up here, let me just make it a bit wide and I'll calculate and tell what's the value of theta, please. Please take note that theta is, what is theta? So theta, if you notice, 3 theta by looking at angle AOB is 90 degrees. Oh, theta is 90 degrees means pi over 2 in radians. So AOB is 3 theta. So you can easily see on the picture, remember the 3 parts, that's how it became 90 degrees, or pi over 2 in radians, remember pi over 2. So all from here we can choose selectively, that's the reason why. So pi will be in the first one, 30 degrees, or in the second one, pi over 6 radians. Okay, so we got pi over 6 radians, or 30 degrees. Why am I having these two values, maybe thinking? Because the nature of the formula I'm using. So the first formula, the top one, remember I said the Edmond's formula a bit sensitive to this. The red one at the top is using in radians. So now I'm going to emphasize that you understand. So this is radians. This is pi over 6, right? So pi over 6 means we put in pi, sorry, I just straight away put in pi over 6 times half, pi over 12. We're feeding this answer here. Then we're feeding the green answer, 30 here. Sorry, I put around the circle. I just put arrow here, but it's understood at the corner there. So sine theta over 2 means now sine 30 degrees over 2. Because here I want to use sine 30, easier to think than pi over 6. Okay, so 30 is half, right? So half over 2, then it goes like that. This is 1 over 4. Okay, we seem to have gotten two values there. So let's calculate the area of that, what do you call it? In Malay, we say tembering. The Malay word is coming. So English word is not coming to me now. This one, huh? This area. So area, let's just call it A1. This area of A1, or tembering lah. Okay, is equal to the area of the sector POQ. Segment, is it? Segment, yeah. Sector POQ. Okay, sorry. What a horrible handwriting I have. Okay, POQ like that, minus the area of the triangle in green. Area of triangle. Okay, sorry, let me just put my this one. The alarm. Okay, area of triangle. What is the one? POQ. The difference between the two is that slight extra part. Oh, then we realize today we just take the red number. So now you realize all the colors have meaning. So that is the pi over 12. Just leave it in terms of pi. Please don't try to put decimals unless they ask. No point. This is more accurate. Pi over 4. So if you want to write it as a single fraction, just make the denominator same. That's about the what we say simplification needed at this point. So it's more accurate when in terms of pi. So it times this one by 3 on the right hand side. So pi minus 3 whole thing over 12. So we have this nice result here. Why did I calculate this area of A1? Because even though I didn't ask for that, because now we're going deeper. So the shaded one, the colored pink. So I'm just going to use pink color then. Area of pink part. I just put pink part, easy, huh? You'll know what I'm talking. Is equals to, now we look at the thing. Oh, there's an area of trapezium. You'll notice there's a trapezium PQRS. So it's a bit tough question. I think these are challenge questions. Okay. The real exam, they won't ask so many details, I think. Unless they're going to build it up. Okay, the mind we learn. That's how we learn a few things. We can see how geometry can be deep also. PQSR, must call it either clockwise or anti-clockwise, plus that A1. So that's the reason why I wrote it like that. And area A1. So let's write it the same way. Area A1, cannot read the things. So let me just modify that, please. So just write like this. Area A1. So let's write on top of it. Area A1, which we found from here. So the color also tells you which step and which numbers we're taking. Okay, almost there, just almost so close, but yet not there yet. Okay, let's try to calculate now the area of this trapezium. Okay, I almost got misled into doing an integration equivalent. Then I realized that is way more nasty. Actually, something interesting. You may wonder why the integration cannot, that kind of weird integral there, right? Because even if you think ahead, some of you may know the integration formulas. That's how they discovered some of the other definite integral formulas. You know what I'm trying to say? That means they link to circles like this. They count this in this way, right? They put it generally. Then they put the other integral that looks difficult, that they cannot find the formula earlier. Then they put it equal, there's a whole list. So integration got sometimes formulas in very advanced texts. So they play around with that, count the same thing in different ways. Okay, just mentioning that. Now, just came to mind. Okay, let's do the area of the trapezium PQRS. And how can we find the area of the trapezium PQRS in terms of this? So we need to find the length of PR. So I'm just going to write the formula here. Half of PR plus QS. PR plus QS. And then multiply by the height, which is RS. Okay. And then this part we already done. So we know this is going to be pi minus 3 whole thing over 12. Okay, pi minus 3 whole thing over 12. Now, how about this? PR and QS and RS, how do we find that? Okay, that's going to prove a little bit of challenge. That's actually another triangle part. Okay, so what I need to do is, wait, I'll just take a screen grab of this. I will take a screen grab and then I'm going to modify it so that we can, right, there's not enough space to do that part here. So what I'm going to do is up to here, no worries, just give me a minute. I'll modify the picture, see how we clear this 1 minute. Fill drawings S2-1, quite timely because it's the first part of the solution. And then from here, I want to take another screen grab of the part I want to repeat to use for the second part. So that part, what I'm going to do is, okay, if you notice that the time is less than 1 minute, so please reconnect to see that part. I'll just quickly take my photos lah, so that I can retrace this thing. Okay. I need 2 photos, this one and this. Hopefully it doesn't end by the time I figure this out. I want this picture. Sorry. No, come on. Okay, please reconnect. Don't forget. This one. Okay.